right, we've reached 2:03, so I'd like to get started on today's presentation. I'm hoping everybody can see the screen. You should see a splash screen that talks about Arctic, HashiCorp Vault, and OpenShift integration. And so that's what we're here to talk about today. We're going to explore the HashiCorp Vault product in a little bit of detail. Then we're going to look at how we can use a couple different operators that come with OpenShift to provide seamless integration of our Vault, which you're going to learn about, down into our Kubernetes environment, presenting them as secrets, which can be consumed by other applications. So the real byline for today is that security really shouldn't be an afterthought. A lot of times we know that they're, the overlords of get the things delivered, get it out fast. A lot of times developers will take shortcuts. And that leads to a ton of disaster and a lot of sleepless nights for security teams in organizations when we have to bolt on security after the fact. So one of the things we really want to get across today is how you can leverage these two platforms to really elevate your least privileges and your overall security posture within your organization. So hopefully I can have this work. So the agenda for today, we're going to do a couple of introductions. We have some really good speakers, both from Arctic, from HashiCorp IBM, as well as Red Hat today, and I'll introduce those guys shortly. Adam, who you're about to meet, he's going to take us on a little case through about why Arctic, HashiCorp, and Red Hat is such an effective sort of triumvirate when it comes to integration, modern infrastructure adoption into microservices and declarative and all that good stuff. We'll examine some of the key benefits of the integration. So both with Adam and with Tim, we'll take a look at the Vault as a product on its own and see what the features it has and why we would use that. Once we have a clear understanding of what Vault is and what Vault can do, we're going to look at how we can integrate Vault, which is where we're going to store all of our credentials, secrets, and really sensitive materials, how we can use the Vault secret operator, which we're going to show in detail, as well as the Vault configuration operator to assist in the integration of Vault so that applications running on your Kubernetes cluster can use secrets in Vaults just as they would Kubernetes secrets. And then you can see here we have a little bit of a 5, 6, 7. I'm going to lead us through a little demo afterwards. We have an instance of Vault set up. We have a couple CRDs from VSO configured and a simple application that's reading secrets. And so we'll take a look at some of that integration in real time. And then we'll do a wrap up and we'll talk about next steps and we'll do any Q&A at that time as well. So a little bit of introductions. With us today on the panel, we have Tim Jung, a colleague of mine. He is a delivery consultant here at Arctic along with myself. We have Adam Cardell, who's a senior PS engineer with HashiCorp IBM, and he's going to speak to a lot of the partnership and engagement stuff that we're doing with the HashiCorp suite. And last but certainly not least, we have Ryan Clements. Ryan is an ecosystem solution architect within Red Hat, and he's going to help me provide some color and some aspects when we get into the OpenShift area. So what I'm going to do, guys, is I'm going to give each of you 45 seconds to say hello, introduce yourself. You can talk about the fact that some of us are from Barrie and some of us are not. Tim, why don't you lead us off and introduce yourself, say hello.
Hi, everyone. My name's Tim Chung. I've been a delivery consultant here at Arctic for approaching 4 years now. I specialize in the HashiCorp tool suite, but I've also done a considerable amount of work on public cloud and on-prem systems, mostly around platform engineering. Adam?
Excellent. Great, Tim. Thanks to have you aboard. Go ahead, Adam.
Hey, good afternoon. So Adam Cardell. I work for HashiCorp, an IBM company now. Been here about 4 years. Did 2.5 years on services, primarily around Terraform internally. Then switched to the partner team, so I support Canada and then the East United States for the partner ecosystem. I was just thinking, fun fact, I've been a cloud quote-unquote engineer for about 10 years now. So kind of been in the industry a while, and it's just cool to see how it continues to change.
Excellent. We're really happy to have you here today, Adam. Thanks a lot for joining. Ryan, why don't you go ahead and introduce yourself as well?
Yeah, my name's Ryan Clements, and I've been at Red Hat for about 3.5 years now. Before this, I was a data center infrastructure manager for a large corporation in operations, and that's how I lost all my hair. Before that, I was in more operations and consulting and development. Hey, I love it all. And one of my things that I was doing over at the last corporation I was with before I came to Red Hat was working specifically with HashiCorp's, Terraform and Red Hat Ansible, and a lot of containers as well. So this is I love this kind of stuff. And, a lot of people asked a long time ago, well, which should we use, Ansible or Terraform? And I said both, right? There's no right answer. And we'll get into that. I don't want to, but I just wanted to say, like, I love this kind of stuff. So I'm glad to be here. Thanks very much.
Really good, Ryan, and we're really, really happy that you were able to pencil us in right at the last minute. So I really appreciate you jumping in. For myself, sadly, there's not a picture on there. I have slightly a bit more hair than Ryan's, but not quite as much as Adam. My name is Daniel Smith. I recently joined Arctic myself. But in terms of my career, I have 23 plus years doing carrier grade, production grade, open systems. I started back in the trenches with Solaris back in '99, all the way through the Perl Python eras up through virtualization, and now with containerization. And I guess I've been called an expert generalist. I guess that means I like to get my hands dirty in just about everything. And I generally focus nowadays on a lot of Golang operator development, a lot of low-level Kubernetes operator style stuff, and more recently getting into a little bit of the UX and what I guess they call full stack nowadays. So again, really glad to have the three panelists here with me today. Let's get started. So when we talk about Arctic, HashiCorp, and Red Hat, what we really want to enforce here is a couple things about Arctic, sort of tooting our own horn, but really talking about the partnership. So, I mean, Arctic is a HashiCorp system integrator, as well as a reseller. In addition to our partnership with HashiCorp, we're also a premier top partner with Red Hat. And so when we look again at that sort of triumvirate or three pillars, we see that Arctic is carrying a lot of certified capabilities and hands-on experience. So you've heard people talk about Ansible, OpenShift, and then when we look at the HashiCorp product suite, things like Vault and Terraform and Console come into play. And Arctic is recognized as certified experts in these fields, along with a lot of security competency within our organization. We're a hyper-specialized partner status within HashiCorp, and that was a designation that took a lot of rigorous sort of technical validation and delivery excellence. I'm hoping maybe Adam will speak to a little bit about that. And what this means is that, Arctic, working with HashiCorp and Red Hat, we really can provide that deep expertise around the broad ecosystem of platform engineering, platform security, and modern infrastructure projects to really help advance our customers and their organizations in terms of where they are in their evolution, whether that be you're just getting started in microservice, you're a full-blown hybrid cloud where you've got clusters all over the place and you're looking for hardware management, or if you're a legacy organization and you're looking to institute some new styles of operation. Zero touch is very popular nowadays. Sorry, zero trust is very popular, as well as zero touch when it comes to deployment, and a whole range of options there. So this slide is really a little bit of tooting the Arctic horn and to show that we have this partnership with HashiCorp and Red Hat. It's backed by a ton of technical validation and a lot of use cases and actual engagements. And so to that end, what I'd like to do is I'm going to pass the mic over virtually to Mr. Adam. And maybe, Adam, you can get started with talking about Vault and OpenShift. And we'll just start here with the unified platform for infrastructure.
Sure. And I'll we'll set the stage a little bit before we get to the integration itself. Yes, HashiCorp, we were founded on the premise of really consuming and automating cloud resources. I think that's how Terraform kind of came to market, which was kind of the birth of infrastructure as code, right? I think back before we did ClickOps, right? Or you had to hit APIs, and we said there's got to be a better way, right? So kind of the Terraform was birth, the birth product, but not far behind it was, well, hey, when you're in the cloud, there's a lot of secrets, right? We got keys we got to store, we have username passwords, database passwords, and really Vault came out of this need to, well, hey, if I can provision cloud infrastructure, I also need the security component of cloud infrastructure. So what we say is this is doing cloud right. If you want to, you switch to the next slide there.
Sure. Sorry.
And what's doing cloud right? It's really how we can automate cloud infrastructure. So as a company, right, we have over 500 million annual downloads, 4,800 customers, and 490 Fortune 2000 customers, as you see by this slide. You can do the next slide. Sometimes our tools are better known than the products themselves. I think, as Brian was kind of pointing out, we have Terraform's kind of the flagship product when we call infrastructure lifecycle management. And then we also have what we call security lifecycle management centered by Vault. Then the other products kind of extend on the capabilities, right? Boundary kind of gives you that PAM, privileged access, right, for users to your secrets. And then we have Packer kind of makes better images. But what we found is we kind of sit here right in the heart of DevOps lifecycle or app lifecycle, right? We help you provision, we help you secure, we help you govern and audit, right in between your DevOps workflow. Before we go to the next slide, I want to set some context because it's really what brings us here today. So HashiCorp and IBM, we announced our merger in April of 2024, right? A little over a year and a half ago. Since that time, and even today, I think one of the most talked about integrations has been Vault and OpenShift. But keep in mind, this is relatively new for us, right? We didn't get formal approval so earlier this year. And then we couldn't even start talking as employees until June 1st. So the kind of our initial go-to-market motion and some of the slides you see today are kind of, I would say, version 1. Over time, our integration is going to get deeper. So that's kind of where we're at today. And you just go to our next slide. So as you guys are aware, OpenShift is a behemoth of a platform, right? Not only does it help you manage Kubernetes, but you're also syncing to clouds, right? You're syncing to repositories. You're bringing in directories, right? All these things are secrets. Currently, in the standard OpenShift setup, these are managed by different people, right, and different platforms, as you can kind of see by the key there at the bottom. And what we want to do is kind of centralize all that, right? So not only do we have one tool, one person responsible for all your secrets, we can also audit that real simply, right? So this is kind of where the play comes. As I said, it's probably been, along with Terraform and Ansible, the two have probably been the yin and yang, right? The most popular plays ever since we announced our merger. So it's kind of cool that we get to cover this one today. We can go ahead and go to the next slide. And this is kind of what it would look like, right? So Vault becomes central for all things, right? We can do certificates, we have PKI secrets engine, and we can hook to your cloud natives. So AWS, Azure, whatever you want to bring in, manage your database credentials, key value pairs, simple stuff like that. And then we also can verify identities, right? Whether it be LDAP or whatever your third-party identity provider is, right? We can validate your identity, right? Give you the secrets you have access to, and bring it into the OpenShift workflow.
Sorry.
I'll just preface it before you do the better the other slide. Like I said, this integration is more likely to change. As a matter of fact, we have HashiCorp coming up at the end of September, so we'll probably have some announcements for some better together stories between the two products. But what you're going to see here today is kind of our initial integration. Like I said, it'll probably get better over time. So let's go to the final slide.
Excellent. And so I think.
Yeah. Oh, yeah. I can speak a little. So yeah, with Within Canada, I think Arctic's kind of our go-to partner, right? We've had a lot of successful. I think you got started as a security-based company for us, and then kind of bridged real quickly into also doing Terraform engagements. So I say you're kind of one of our go-to partners in Canada, and I know it's expanding to the United States. Right, we're in big banks together. I don't think we use companies, big banks, big service providers. Right, we've had Arctic there kind of for some joint wins, and kind of to highlight some stuff you said. You've been with us since 2017 as a partner. And then you also have our highest tier. We call it hyper specialized, right? So that means you're bringing multiple experts. We kind of push you guys through a test for competency. You have to have field work. So all that's true, right? To kind of make sure you go-to partner. And the other cool thing is you have that same type of relationship with Red Hat. So the expertise you bring around Terraform and Vault and our other products, you guys also have with Red Hat. So what we find is even internally, we don't have that expertise of these third-party integrations. So we could get a partner like Arctic in here that does have the competence on both sides. Usually that will lead to success for our customers.
Thanks, Adam. And I mean, I think that's really excellent. And you know, you mentioned HashiCorp coming, and I know a couple of weeks ago there were some announcements about the new radar feature in Vault. And so, yeah, I think it's going to be really exciting in the coming year to see how, you know, the integration that we're going to demonstrate today is going to evolve. And there's a lot of different ways to go. I know there's lots of discussion in the Kubernetes forum, you know, as 133 and 134 are starting to roll about, you know, how we can get to secrets management without role-based access. And so I think it's really an interesting time to see this evolve. So thanks a lot for your comments and your input there. I think what we're going to do now is I think we're going to move over to Mr. Chung, Tim, and Tim is going to give us a little bit of a treatise, a little bit more of a deep dive into Vault's technical features and the overview. Take it away, Tim.
Thanks, Daniel. So I'm going to go over Vault, exactly what it is and how you might want to use it. So Vault is HashiCorp's secrets management tool. And in the context of Vault, what a secret is typically it's a set of credentials that allow you to access external systems. These can be secrets for human users or machines as well. And Vault, so Vault's primarily a security tool, and among its key features is it provides secure storage of static secrets. In the center of this diagram here, you see the third item down from secrets engines is static KV. So this in Vault terminology, a secrets engine is a component of HashiCorp Vault that can manage, I guess, a particular type of secret. And in the case of static KV, this is just basically a key value store that stores static data. But where Vault really shines is in its ability to dynamically create secrets, provision secrets for a requesting client. And if you look at some of the other, one I'll highlight is the fourth one down, database. The database secrets engine, what it will do is when an authenticated client requests a database secret, Vault, you can configure Vault to connect to said database and provision a user with a particular set of rights, and return said username and password to the requesting client. Now, this set of credentials is going to be, as with all dynamic secrets that are provisioned just in time, it will be attached to a TTL, a time to live. And what Vault will do is when that TTL expires, it will go ahead and connect back to the database and destroy the user account that it created. So if the username and password gets compromised in any way, it'll only be valid for a very limited amount of time. And if you want, Vault also allows you to force the revocation of its secrets should the credential become compromised. And Vault is, as a security tool, you have to authenticate before you can make any requests to Vault. And here, Vault supports a wide variety of authentication mechanisms. A lot of them for machine users and also human users. So you can configure Vault to allow humans to authenticate using their identity provider, such as Microsoft Entra ID or Google Workspaces or Okta. And also, you can configure Vault to allow machines to authenticate using, say, cloud credentials, or if you're running on Kubernetes, you can authenticate the Vault using Kubernetes service account tokens. An additional feature of Vault is that it has a what it calls the transit secrets engine, which implements encryption as a service. If an application needs to encrypt data, typically what it will do is it will import some sort of an encryption library, but it will have to manage keys, and that can be fairly complicated. And what Vault allows you to do is to offload that functionality onto Vault itself, where when you an application can authenticate the Vault and then send data to Vault. Vault will encrypt the data. Vault will hold the encryption keys, encrypt the data, and restore or return ciphertext to the requesting client. And it can also do the reverse. It can, if you send it ciphertext and ask it to decrypt, it can do that as well. So those are some of the key features of Vault. Daniel, can you go to the next slide?
Yep.
So some of the more common use cases of Vault, given its functionality, when most people start using Vault, their intent is to reduce secret sprawl. And by secret sprawl, what do we mean by secret sprawl? In modern applications, modern applications tend to make use of a lot of third-party systems, and authenticating to those third-party systems requires credentials. And as systems grow and get larger and more complex, the number of secrets continues to grow. And keeping track of them, which ones are in use, which ones are deployed where, that can get very complicated. I remember when I was in ops, when I joined a new team, I would be exposed to a lot of secrets. And oftentimes I would ask a question like, hey, what's this secret for and where is it deployed? And more often than not, the answer would be, I don't know. So I would follow up with, can we get rid of it? And no one would ever say yes, because no one wanted to delete a secret and then cause production to go down. So what would invariably happen is that we would accumulate more and more and more secrets, and no one would know. You get this large group of secrets that no one knows anything about, but no one, everyone's afraid to rotate or revoke any secret for fear of bringing down production.
So,
And what Vault
Tim,
does is it allows you to, rather than manually managing secrets, it allows you to automate the deployment of secrets so that you can have all your secrets in a single place as a single source of truth, and you can gain visibility into which secrets are in use and where. Vault has an audit log that allows you to see, gives you visibility into what clients have requested what secrets and when. It also, as far as secrets lifecycle management goes, this is where dynamic secrets really shines. With static secrets are stored in Vault, and clients are allowed to access the secrets, but the lifecycle is managed external to Vault. But with dynamic secrets, the entire lifecycle is managed by Vault. And by lifecycle, I mean the creation of the secret, the distribution of the secret to its clients, the revocation, and the renewal of the secrets is all automated through Vault. Another common use case is certificate management. Generating, rotating, and revoking certificates is often a manual process that, depending on the size of your organization, could take hours, maybe even days. But with HashiCorp Vault, you can that can be reduced down to seconds. And finally, with the Transit Secrets Engine, as I mentioned, the Transit Secrets Engine provides encryption as a service, where HashiCorp Vault holds the encryption keys, and clients can send Vault either plain text or ciphertext for encryption or decryption purposes. And those are when clients start using Vault, those are among the most common use cases that drive adoption.
You know, Tim, and I mean, to speak from a little bit of experience, you know, secret sprawl is everywhere, especially when we're talking about Kubernetes development. You have secrets where I have application developers who are just dropping them as environment variables, or even worse, hard coding it in, making database connections or external API calls. And so, I mean, secret sprawl is a huge issue. Especially when we start to look at some of the GitOps and some of the SecDevOps responsibilities, it can get out of hand. And I think, you know, that's one of the really interesting features that's coming out of Vault is Radar. And if I follow the feature correctly, it's the ability for Vault to go out into your various SCMs, so your GitHubs, your GitLabs, and suck out those secrets and put them into a central place. The net being that your security engineers within your organization sleep better at night, rather than having to constantly scan through repos to find secrets and then go chasing down developers. And I think the one that really stands out for me is certificate management. I have been in tons and tons of maintenance windows and nightly rollouts, and everything goes well, except that the certificate expired on the ingress gateway, and then you have, you know, 403s and 404s. So I think certificate management, you know, especially when we're talking about things like Consul, Istio, or any of the other ingress gateways, to me, those two cases are the prime ones as a guy who deals with metal LB and ingresses all day long. So thanks a lot for that.
Daniel.
Yeah, for me, sorry, secret sprawl is the feature that resonates most to me. I remember when I was in ops and a senior developer's laptop got stolen, and we had to rotate all of our secrets. And when it was a manual process, it took about a week between coordination between teams and creating new secrets, running deployments, and revoking old secrets. Every time that happened, I lost a week. And ever since Vault was deployed, that turned out like that was completely hands off afterwards. So we'll just say let the secret expire. It'll be rotated automatically. Saves me so much time.
So Tim, you mentioned that every time that happens, did a lot of senior developers' laptops get stolen there?
Well, it wasn't just when they got stolen. It was every time a senior developer left the company. It's good practice to rotate. If they had access to a secret, it's good practice to rotate it. And same with operations, people in operations. If they had access to a lot of secrets, then every time one of them left, we'd have to rotate them all.
So yeah, operations is a lot different than development, isn't it? Like we are on the line for security because security doesn't actually do these things. They just say what needs to happen. And it's us operations guys that lose hair trying to make it happen, right? And my favorite is when you have developers putting secrets in Docker files and putting them to a public GitHub.
Yeah.
All right, guys. So
a lot of fun stuff.
We're pushing a little bit for time here, and I'm sure all of us could sit here and talk about horror stories from the trenches and stuff like that, but we'll actually move on a little bit about this, and we'll talk about, why Vault for OpenShift. And I think, Adam and Tim have really given us a nice sort of backgrounding. So we know that from a security engineer and from an organizational point of view, we want our secrets to be consolidated in a centralized location that has things like policy controls for identity about who accesses them. We have authentication, which ensures that you only get the right thing. We have audit policy and stuff like that. And I think this is great. However, I put my developer hat on, and then all of a sudden I have this issue of, well, I'm running a bunch of Kubernetes applications. So Dan, the security guys have put this new Vault in there. Does that mean now that I have to embed the API calls to Vault to get my secrets that I want to use for my application? And you could, of course, do that, and you could teach all of your developers that they have to adopt the Vault API. However, that's going to take you to a point where they need to have a secret in order to talk to the Vault. And so in order for them to get to the Vault over the top, as it were, we're going to have to give them a secret. And so that kind of creates the problem. So what we'll talk about now is why we should use Vault on OpenShift and how we can make it better so that me as an application developer, I orient to the standard Kubernetes secret object. And we'll look at how OpenShift along with VSO will act as that intermediary between Vault and my Kubernetes secrets to ensure that we have synchronization. And so when we talk about Vault for OpenShift, we're talking about centralized secrets in governments. So we've really talked about that. Tim took us on a journey about the dynamic short-lived credentials. And this is where we really want to get into, is that we want that platform native, that cloud native integration. We want our developers to only develop against the standard Kubernetes CRD set, CR set, or their own CRDs by extension, rather than to have our developers have to learn APIs of different endpoints. Now, there's lots of camps about this. Some people say, no, we should just go direct and handle it a different way. But for the purpose of today, we really want to reinforce those least privileges and cloud native approach. And so up here in this slide, we've kind of already gone through this, secrets management, certificate management, key management, data protection, as well as isolation. And when we add that Vault on top of OpenShift, we are allowed to do things like authentication and SSO up to the Vault, impersonating one of those identities. We can use it as far as doing GitOps. We talked about how we can use the certificate management capabilities to make sure our service meshes are always up to date. We can use these secrets to make sure that when I'm accessing our registry where I've just built our application, I have the right secrets, even for things like CVEs. When we're running our DAST, which is dynamic application scanning, or SAST, static application scanning and testing. Results. You know, a lot of times we just run our SAS scan, we send it up to a Sonar Cube or something like that, and we forget about it. Well, certain people may or may not take advantage of the fact that Dan's version of this app has 100 CVEs. So we want to also start to keep control and to lock down not just the app and the things to get in, but also the auditing and things like scanning and observability. Now, of course, one thing that we skip over very, very quickly and why we talk about OpenShift is because it runs everywhere, right? So you can run OpenShift on physical hardware, single node, arbitrator node, 3-node, 50-node. It can be run on virtual machines as well as bare metal, up in the private cloud. So if you want to spin up your own RHEL OCP stack in your own DC, public cloud, as well as the edge offerings with SNO and Arbiter. And so, I mean, when we take a look at this stack, we end up having a full-blown security platform to allow us to do strong secret or least privilege management from an infrastructure up point of view. So I'll breeze through these a little bit, but some of the principles of least privilege that we really want to enforce with OpenShift and Vault. We want to establish identity with Vault auth methods. So that means that when we log into the Vault, we're logging in with an identity. And as Tim outlined, that could be hooked up to various different IDPs, Cloud SSO, and stuff like that. And it establishes the policies of who and what has access to which sensitive secrets or materials at a given time. And so that's really that just-in-time least privilege aspects that we're looking for. Identities are, of course, maps to namespaces, so you get that granularity that OpenShift really extends on top of the base Kubernetes via their project CRDs. So we extend some of the granularity available within the namespaces. From a Sentinel point of view, we can limit requests to a specific project. We can limit the hours when keys are allowed. So if we, suspect or we don't want things to happen, like let's not rotate all of our certificates at 1 p.m. on a Monday when it's a busy day. Maybe we limit our requests for revocation and cycling to Sunday night in case there are, momentary disturbances as the pods restart. So, I mean, the real key things that we're talking about here is, the OSS sort of community open source approach, granularity of control, our ability to federate and to make it as explicit or implicit as we want. The fact that we can control the group, so access is gated by certain approval steps if you want to implement it. And the big thing, especially for organizations that are concerned about regulations, such as FIPS, NIST, some of the HIPAA or GPDR regulations, more and more, it's not just enough to say, ooh, it's secure. We have to show an audit trail. You have to show traceability, sometimes all the way back up to the commit. And that's really what we're talking about when we combine the OpenShift and the Vault together. Now, when we talk about integration of Vault down into an OpenShift, there are two operators that come to note. The first one that we're going to examine, and we'll look in detail showing in the live demo, is the Vault Secret operator. The Vault Secret operator allows for this middleman approach where some third party, maybe your security or your organization, we are centralized around all of our secrets and assets are in this vault, but I am an application developer down here who wants to deploy his pod, and I don't want to make the API calls for whatever reason. I have to stick a secret in here to know it. I don't want to learn a new API. I'm a real curmudgeon, and I want to use cloud native Kubernetes approach. So what we have is we have secrets up here, not Kubernetes secrets, but secrets being assets in a vault that I want to expose or express as Kubernetes secrets down here. And VSO is the tool that allows us to do that. And so VSO will allow us to sync vault secrets into local Kubernetes secrets that are fully namespaced. It allows us to have full control over what secrets are expressed, when they're expressed, which namespace or project they can be expressed to. and using the Kubernetes role-based RBAC system, we can also police within the namespace which service accounts are allowed to access what. It allows us to do things like rollout of restart capabilities. So we can just roll out new versions of pods, either because a secret has changed or a secret has changed up at the vault, or a secret has changed down here because a result of the syncing. So you can do things like rotating your pods based on secret rotation or revocation, as Tim had talked about. And why are we doing this? Well, it accelerates application deployment. So if I am a guy who's doing, and I do operators and I do Kubernetes application microservices all day long, I really know whether it's Go, Python, Java, whatever, I really know the Kubernetes library. And so I'm really, really used to dipping into secrets, dipping into different CRDs at the Kubernetes level. And then along comes a big bad overload and says, we're moving to a centralized vault. Well, if you're just one developer with one application in your organization, maybe adopting that API call is not a big deal. But if you're a huge organization, you have multiple product units and multiple development units, and then you say to them, hey guys, all at once, thou shalt adopt this API and move away from the Kubernetes native approach, I wouldn't say you'll have a rebellion on your hands, but you might have a little bit of a revolt, vis-a-vis Andor or something like that. And what we really want to do, and I think at the heart of, Ryan, what you mentioned as operations guys, it's to get the control over the secret policies and the secret management back into the secret operations team. So because of the heyday and the arrival of microservice and the secret sprawl, we know that secrets will be put in environment variables that cause this pod to be built. They could be baked into a Docker file, heaven forbid. Somebody might have cheated and just put them as plain generic secrets within the namespace and stuff like that. And so having a construct like this really returns the ability to affect effective policies and secret management within your organization. So the two key elements of the VSO, it's an operator. So we have another session on operators. Quick and dirty, an operator is a way of combining complex organizational processes or activities into a single container and then instrumenting it based on a Kubernetes CRD. There are lots of things about operators. I won't go into that today, except to say that when we install the VSO, it creates a bunch of CRDs that are available to us. The operator writes the source vault secret data, so up in the vault, directly to a destination Kubernetes secret. And this ensures that any changes that are made up in the vault, so as we'll see in the demo, I have a secret, I'm going to change it. They're replicated over down into the Kubernetes cluster very, very quickly. And in this way, an application only needs to have access to the destination secret. So when I'm developing my Kubernetes manifest and I have an app value or a secret I need to give, I only need to know the secret name on the cluster. And in that, my application and me as a developer, I actually never see the secret. I only architect against the secret name. I don't necessarily even need to know what's inside the secret. And so we're going to take a look at this one in a little bit more detail in a couple seconds. When you install the VCO, and this is really funny because it says VCO, so I think I have my slides backed up. We have the VSO Vault Secrets operator, and it produces a bunch of these CRDs. And so when you click through the console, if you use the operator hub or you install it manually, you'll end up with this view. And for the demo, we're going to take a look at the three basic CRs: the vault connection, the vault auth, and the vault static secret. The vault connection defines where my vault is. My vault auth defines who my cluster connects to as it relates to the identity in vault. And a vault static secret defines what secrets in vault I want mapped down to my cluster and what they should be called. When do you use vault secret operator? So when should you start to get involved? Well, if you're starting a new project or you're doing a replatforming exercise, now is the perfect time. For anything that is more than 1,000 pods, or 1,000 plus that are going to be doing rolling updates, and you're running a production cluster, I would say 1,000 is probably even too high. By the time you break 100 pods, custom pods, you're probably already starting to have secret sprawl all over the place. For secrets that are used by multiple pods. So I think we talked about this before. If it's a single developer and I'm a single pod, I have a lot of control. But in a distributed development team, I could have me developing something, Gevorg doing one, Mahan doing another, Simon doing one, and Tim doing one. And then along comes our secrets engineer, and he changes the secret, and all of a sudden, a bunch of our pods break. And so this is a really good use case for that. If you're getting stung in your cycle times by secrets integration and management, Tim and Ryan gave a good use case of, hey, I just joined the org. Where are all our secrets? Here is this OneNote page that has all of our secrets, and that kind of stuff. That's really, really slow. So a quick refresh or redo of the supported environments and capabilities of the VSO. So for authentication, and now we're talking about the Vault Service Operator authenticating outbound towards a vault. It supports all of the methods that Tim outlined. So we have Kubernetes, app role, JWT tokens, AWS tokens, Google Workload Identity, and other IDPs. From a secrets point of view, the VSO supports all the secrets that the Vault supports, so static, dynamic, as well as PKI. The VSO has been working since Kubernetes 122, so it's been around for a while. Works with the Vault 111 or greater, as well as the HashiCorp Cloud Platform Vault dedicated deployment, if you're running that. While, of course, the VSO comes natively with OpenShift, since it's just an operator and it matches Kubernetes, since OpenShift is Kubernetes, you can also roll it out on EKS, GKE, and some of the other Kubernetes distros that we're thinking about. So we're running a little bit long on time. We will talk about the Vault Config Operator briefly, and the Vault Config Operator is a way of using Kubernetes CRDs to configure your Vault application. So the VSO integrates downwards from the Vault to present secrets, and the VCO allows you to configure upwards from your Kubernetes cluster towards your Vault. For the sake of time, we're probably not going to get to too much about VCO today. So what I'd like to do is, we have like 10 minutes left. I'll get into a little bit of a live demonstration flow here. And to get started, we'll paint a little bit of a picture. So here I have a Vault instance. And as Tim had outlined, we have secrets engine, and I have a secret engine called secret. And within there, I have a secret called hello that has a couple key values within it. And so keep that in mind while we continue on with the demo. Over here, if I can find it without showing it. So here I have my console to my OpenShift cluster, and you can see that for the operators of this demo, I have MetalLB installed, and I have VSO that is installed. And what we have defined is we have a Vault connection, and this basically just points to the URL or the route in OpenShift as to where my Vault is. I have the Vault auth, and this is configured to use the role. As Tim has outlined, we have different access policies. We have this app role, and this app role has certain permissions. So when we define the way that VSO authenticates over this connection, we define that same app role within the CRD, and you can see it. It's called mount app role, and this one is called app role. So that tells our VSO what it should connect to our Vault as. And the last CRD that we want to talk about is a static secret. And so for today, we'll just look at this foo secret. And inside this CRD, you can see that I say, hey, create a new secret, call the secret. Now we're talking about Kubernetes secret. I want you to call it synced foo. I want you to start from the mount path secret, and I want you to use the key value store that I called hello. So if I go over to my secrets engine, you can see that I'm saying, hey, whatever values, key values that you find within hello, I want you to create a secret on the cluster called foo secret. So that looks all fine and good. And if we were to go onto a cluster to have a little bit here, and I do gut secret, we can see that synced foo is a secret that has been created by the CRD. And in fact, and we'll see in a second, it's constantly being updated with whatever the value inside our vault is. So the last thing I'll show you guys is I have a very simple application that I've deployed on OpenShift. And you can see this will change every 2 to 3 seconds. And all it's doing is printing out the value of the synced foo secret, which, because of VSO, should be the value of our keys. And to give you an idea of how quick it works and how nice the integration is, I'll come over here and you can see right now it's showing a new key and change again. I'm going to delete this one and I'm going to call this live demo update. And I'll click save. So I've just saved this in the vault. In the background now, the operator is going to update the secret that is within the cluster. And then you can see my application, which is just doing a read from the secret all the time, picked up that new value right away. And so, demo key added. This is the added value showing quick sync. So if I add that in there and I click save, we wait till the next refresh. So 53, 1, 2, 3. We can see that the value that I added in the vault has instantly been reflected as a Kubernetes secret and is available for my application. And my application, again, is just a simple pod that all it does is read from this secret every couple seconds for the state of this demo. And in that, we can see that really it's seamless. And I'm only demonstrating today 3 of the basic CRDs. I think Tim has talked a lot about dynamic secret action. We've talked about certificate secret action. And what we want to talk about in the flow, even though we've gone through it pretty quick, is, we have a running instance of Vault. We expose a route so that we can log into it. We deploy that operator through the operator hub. We create a connection, an auth, and then a static secret. And we can see that that secret is then updated on Kubernetes. Today, we didn't use VCO, but it follows the very similar options. And that allows you to create users and policies in your vault using Kubernetes CRDs. And what I showed in the demo was we had a secret written into the vault. I showed that this VSO synced it into an OpenShift secret, and our application deployed it. So just to wrap up for today, and we'll leave a couple minutes for any questions and commentary in there as well. And sorry, Ryan, if I have missed anything, please jump in. The VSO synced secrets from the vault into Kubernetes. It watches the CRDs to make sure we keep secrets up to date, and it ensures auto rotation and synchronization from the vault down to Kubernetes. The VCO goes the other way. It manages the vault configuration in a declarative Kubernetes manner. It enables Git style workflows so you can configure the vault through YAML instead of a manual CLI. And we ensure consistent, repeatable vault steps across all the environments. And that's one of the key things is it's great if you can do it once. Let's make sure when we do it 100 times, it's always the same thing every time. So we leave it at that. And we really hope that for today, you found the presentation interesting. I want to thank again, Adam, Ryan, and Tim for participating and helping out with the commentary and the presentation. It was really, really great. I am super unfamiliar with the WebEx layout, so I'm going to have a look inside the chat. Yes, indeed, Ryan, encryption as a service. It's another AAS kind of thing, and it's definitely coming up all around the place. Are there any questions in the chat or any comments?
I have a quick question.
Please.
That was awesome. Great job. And you know, it's obvious that we would want to bring out secrets outside of OpenShift and put it somewhere else that can be managed by security operations and not the operators. So question, do you guys know how the VSO updates? Is it a lease base? Is it polling? It can't be polling. That was too fast.
No, well, it's using a watch.
Very good.
So yeah. So what it's doing is it's using a watch. I mean, I looked a little bit under the hood, and to me, it looks like it's doing HMAC hashing. And as soon as it sees the hash change, it does a push.
Perfect.
Or in this case, a pull. But that's a really good question. And I mean, the code is open source. So we could definitely get into how it knows. The best that I can tell, it looks like it's doing a hash differential. And if the hash changes, it just does another push. But I agree with you. It's when I wrote this little app last night just to kind of flex this, I was amazed because it's less than a second.
Yeah.
Now, of course, I'm on a cluster that's not loaded or anything like that, and I'm on a single-use vault. So we would imagine it will scale. But I was really impressed at how quick it works. Yeah.
Very interesting. No, that's great stuff. You know, it's one thing to solve a problem, but it's another thing to solve a problem awesomely. And that was awesome. Good job.
Thanks. Yeah, and I mean, I think this is a very rudimentary kind of example, and we're very much using static. But I think as a security guy, if all of a sudden I know, let's take a look at just my cluster as we're wrapping up. So this is all the secrets in one namespace that I did for this demo. And so I have demo apps, Docker configs, I got all sorts of tokens and stuff like this. And if I'm a security guy, this makes my hair stand on end. If all of a sudden I was to know that, okay, you can have all these secrets, but they actually all come from a third party or a centralized vault. And so that anything you see in here is actually controlled and policied up here, that would make me sleep a lot better at night. So yeah, it's a very interesting field, man.
Because like as you said, security doesn't necessarily do the things that they want. They just execute the policy that they want. It's up to operations guys like us to lose our hair to do it. And one of the problems has always been they want control of everything, and they couldn't. They could have control over a couple things, going to CyberArk or Vault or whatever. But this allows us to really put everything in there, which is fantastic. And you can build a policy around that. So great job.
Absolutely. All right. Well, I think we're at time. So I'm going to shut down the call now. I will again, thanks everyone for attending. If you have any questions, you have the QR code. Feel free to reach out to Tim, myself, Adam, or Ryan if you want to follow up. And I think Robert Tran will help with making sure that the deck and stuff follows up on our Arctic pages. So have a great day, everyone. Thanks again to the panelists, and we'll talk soon. Bye-bye.